And I kind of want to see the differences between the two, because... All right. Doobie-doo-doo. Come here. Little dude. Come here, little dude. Man. What are you? No? All right, so if I wanted just a rough sketch of sine, oh, Jesus. Holy Jeebus. Okay. If I wanted just a rough sketch of sine, I would want to see something like this. Weehaw! Right, that's a rough sketch. The most important thing about sine, really, sine and cosine have the same exact shape. Sine starts at 0. What about cosine? Starts at 1, right? So this would go on forever, right? Jihad. Okay. This one starts at 1, so it kind of does this thing, and then it goes this way. Okay. So this would be so unacceptable on homework if the point of the problem was to give a graph and show transformations and whatever. But this is good enough for just getting a feel for it. If I wanted to move the sine function so it would match up with the cosine, which direction would I move it? Not up or down, because they both go between -1 and 1, right? I don't want to mess with that. I would have to move sine back, correct? By how much?
90 degrees.
Yeah, because this is pi over 2, correct? So if I move sine back 90 degrees, wouldn't it match with cosine? If I took this and I move it back, it would perfectly match with cosine. Is that cool? Now what's weird is, now watch this. The actual rule is this. Let me see if you guys can be cool with this. This is how they write the rule. Well, this is how I write the rule, which is barely something you can call writing. Is that a shift to the left of pi over 2? No. There's two things happening, though. What does that do? Oh, come on. It's normally sine theta, now it's sine negative theta. That's a type of reflection. Which way does it reflect? It's inside. So that's going to be left and right. So it's going to shift. It would take sine and it would flip it. And then it would move it back pi over 2. So it's just a really weird way to do it. The reason we write this way, instead of, what we just said was this. If you take sine and you move it pi over 2 back, so wouldn't that be this? That would become cosine. Are you with me? The reason, got to catch that wascally wabbit. The reason that we write it this way is because of this fact. You ready? And this is kind of good because I need to talk about this because a few people made interesting mistakes. Stay with me now. Can somebody tell me what the sine of A is in this triangle? I said that like it was profound.
A over C.
I love it. Can somebody tell me what the cosine of B is?
C.
Yeah, why is it A over C? Because that's the triangle I'm working with now, right? That's in the base. Cosine likes X. You all with me? Why was the first question easy? Because the angle for the first question was already in the base. Again, I want to really get you guys to understand this. That is the one thing SOHCAHTOA has going for it. But to make SOHCAHTOA the shit that it is, I just rotate the paper. I'm like, goodbye, SOHCAHTOA. Anyway, sorry. Okay, I'll stop. I just wanted to die, SOHCAHTOA. Okay, sorry. So cosine of B is A over C. Now, real quick, what is the relationship between A and B in this triangle? There's a relationship there. They add up to be 90. I love it. Pi over 2, we'll say, right? So that means that, for example, B is pi over 2 minus A. Yes? So isn't cosine of B, for example, equal to sine of pi over 2 minus A? And that's why we write the identity like this, because it more directly relates to triangles. On the graph, we have a quicker way to make these match up. Do you guys agree with me? I just have to push sine back. So graphically, that's the transformation I would use to make these match up, yes? Maybe? I'm sorry, I'm too zoomed in. Graphically, I would use this to make it match up. I would just push the sine back pi over 2. They would match up. This accomplishes the same thing, because it would flip sine and then would move pi over 2 forward. That would end up looking like this. But that's why be so crazy, because it matches up with triangle logic, which is where trig functions kind of live the most. I don't know if you guys are with me or not, but I really want that to make sense, why there's a much easier way to make the graphs match up, but the actual identity is written like this. All right, I'll let that go. Anything else from homework stuff? Okay, well, okay. I really hope I didn't scare you guys from asking homework questions. Again, it's my job to move us on when we need to, so don't ever stop asking questions. Okay. I'll make you stop if I need to. Anybody need the handout from yesterday? There's like a phantom continuation there. It's freaky. Okay. Oh, sorry. All right. So, if you were not here yesterday, obviously go watch that video. So there's a lot that came out of yesterday. All of this came out of yesterday. So the big thing, let me see if I can give a quick rundown. Whenever I have a function, any function, and I've decided, oh, there you go. Any function. What would happen to the graph if I do this, for example?
That's a flip.
Flip how? It's in with the x-axis is left and right, so it's going to flip left to right.
Across the y-axis.
Nope. Oh, I'm sorry. Yes, across the y-axis. Good. It's going to flip left to right. I love it. And that's the way I keep it straight, and it makes sense. Hopefully. Okay. So what would happen if I had f of x and I did this?
That would affect.
No, it's not a reflection. It's not negative, right?
Something of-
That would
the amplitude.
impact the outputs, right?
Because where is the 2? Is it out with the outputs or is it in with the inputs? It's inside. And like somebody said yesterday beautifully, if it's inside, it's the opposite. I love somebody else saying that, because that's what I desperately try to get you guys to understand. And y'all basically understand that. Y'all basically, if I did this, we'll come back to this in a second. If I have this, what does that do? It takes a function and moves it left 1. Opposite of what it looks like, correct? So this one, why is the opposite? Because this guy can approach the bar with $1 or less than he needs, because somebody's there giving him $1. This guy can approach the bar with half the money he needs, because at the door somebody's going to double his money. Don't get excited. I have not seen this happen yet. If I had a lot of money, who knows? I'd like to do something like that, but oh well, I don't. So this is going to compress it. All my inputs can be half as big as they used to be. And what's really cool about sine and cosine is they look like springs. So when I compress it, it actually gets like that, right? Okay, maybe. So like we were talking about yesterday, the Doppler effect. If it's coming at me, it's all compressed, and that's why it sounds high pitch means frequency goes up. It just means it's compressed, and when it goes away, it's elongated. Now it goes, we all do that. We all know that. High pitch, low pitch. Okay. Sorry. So my teacher, I remember he had on a string, he had this little thing that would emit a sound like, and he started swinging it, and you could hear it, you know, anyway, all right, I'll stop. Okay, so what that means is, whatever the number is right here, it's going to affect how long it takes for it to get through a cycle. And we call that the period. So it's going to affect the period. Normally the period for sine and cosine is what? 2 pi. So if I have a 2 out there, it's going to make it pi. It's going to take half as long to get through one cycle. It's going to smush it. This is exactly like it always is, but we just call it a phase shift instead of a horizontal translation. To be awesome, to be honest, phase shift is better. I like phase shift better than horizontal translation. Okay. Amplitude is exactly what you would think it would be. If I make the sound louder, you would think that the wave would get higher. That kind of makes sense. It's exactly what happens. Okay. So we talked about this yesterday. I think we finished this, right? I don't know what I did with my copy that I worked on. Here we go. Did we finish it?
Yeah.
Did we actually graph? Oh yeah, I graphed on another sheet of paper. That's right, because I didn't like the tick marks. Okay. So let's do. I have a handout, but I have a handout about like cosecant and tangent and all that kind of stuff. Well, let's do one more. Let's do a sine one. I think the last one we did was a cosine one. Let's do a sine one. Yeah, let's do one like this. Yeah. Okay. So normally what I'm going to do on a quiz or a test, I would ask you, what's the new period? What's the phase shift? What's the amplitude, right? So you don't have to kind of remember every little detail you're supposed to get. Just like I did with asymptotes, I asked you for each thing. I didn't just say, find all the shit you need and graph it, right? So first question I want to ask you, the one that you can see immediately, but let's see if you guys get this. What is the amplitude? Careful.
3.
It's 3. What's the negative do? Takes the sine and, yeah, now it's going to be a up-down because it's outside. So that's going to be the y-axis, up-down. So the amplitude is 3. There's a reflection there along the x-axis. I like it. So then what about, how do I get the new period? What do I have to figure out what the value of is?
4x minus 2pi
Yeah.
equals 0.
Oh, no, that's how to get the beginning and the end. How do I figure out the new
You
period?
have to factor out 4.
Yeah, I can factor it. I can actually see it already. K is going to be 4, but I have to factor this anyway. So if I take a 4 out, what do I get? Do you guys remember how to? When I distribute, I multiply. So when I factor something out, I
X minus 2 pi over 4.
2 pi over 4, which is pi over 2. Is that cool? Chibit? Yes. Okay, real quick. You could see K from the very beginning. I knew K was 4. But I have to factor anyway so that I can see the what? What can I see now?
The period.
Phase shift, yeah. I can see how much X is going left or right, right? Okay, so real quick, what's K?
4.
4. So what's the new period? Good, it's 2 pi over K, so 2 pi over 4, so pi over 2. I like it. So what does that mean, real quick? Does anybody tell me what that means? The period is pi over 2? That's phase shift. What's the period being pi over 2 mean?
Oh, that's what it ends. Pi over.
What does a period of 2 pi normally mean? That means it takes 2 pi in order for it to get through one cycle. Okay, now how long is it going to take? Pi over 2 to get through one cycle, right?
So it's gonna be 1/4 as much. You're gonna smush it.
Yeah, so what's the step size now?
1/4.
Yeah, pi over 2 divided by 4. See if you guys remember. Pi is being divided by 2 and by 4, so pi is being divided by 8. Okay. All right, let me stop for a minute. And again, I would ask each of these questions. You just have to remember how to do each one. All right? Yes?
So the step size, you get that by dividing the period by k?
No, careful. Well, let's see. Yes, okay. I don't know what I was thinking. Because normally it steps through, and what do I, by step size, don't we have like, we have 0, and then we have 1, 2, 3, 4 locations. Max, 0, min, right? Where it hits its extreme values. Is that cool? Sine hits 0 at 0, it hits 1 at pi over 2, so forth. So those are the key points where it hits its maxes and mins and zeros. So I can kind of just fill in the shape.
So it's the period multiplied by 4? Or divided by 4?
Yeah, so it's always whatever the period is, I want to chop it into 4 spots,
Okay.
right?
Yeah.
Okay. All right. So now I can do, if I want to, you actually don't really have to do this, but where does sine normally begin? Sine and cosine, 0. So if I had set the inside equal to 0, oh, real quick before I forget, what's the phase shift?
Pi over 2.
Pi over 2 to the right. So if I want to see where this new function begins, it normally begins when the inside is 0. So I set the inside as 0 and I solve, and I get something that should look very familiar. It makes sense it starts at pi over 2 now, right? And maybe some of you guys see why this is unnecessary. Where did sine normally start? 0. Now I shifted it pi over 2 to the right, so of course now where's it going to start? Pi over 2. But it just kind of feels good when you're first learning how to do this to have a lot of checks and balances. Now what was the period?
Pi over 2.
So if it starts at pi over 2, where should it end?
Pi over 8.
Up.
It starts at pi over 2. The period's pi over 2, so where should it end?
At pi over 2.
I don't know, you guys. I think you're doing the right idea, but you're just not doing it correctly. All right, well, let's find out.
2 pi over 4.
Let's find out. Let's find out. So it normally ends at 2 pi, correct? All right, so if I add 2 pi over and then divide by 4, get pi. And that, of course, that makes sense. If it starts at pi over 2 and it takes pi over 2 to get through a whole cycle, it's going to end at pi over 2 plus pi over 2. It's going to end at pi.
Oh.
All right, let me stop for a minute. All right, some of you guys, I'm just very happy that looks can't kill. Okay. Otherwise, I'd be dead several times over. All right. So let's say yes. Yeah. So normally sine ends at 2 pi, right? So it's the beautiful. And again, I don't know if you guys see this yet or not, but you actually you don't have to do it, but it's just a beautiful kind of check. So normally sine starts when the inside's 0 and sine ends when the inside's 2 pi. So I just take the inside and make them equal to those two things to see where it now starts and where it now ends. Okay. So let's try to put all this stuff together. Can I zoom out anymore? No. Here, you go up. Okay. Okay. So let's see. Shubit. So I'm going to start at pi over 2. Now, of course, this goes forever. So whatever I do, I'm going to put arrows on both ends, right? But for my one cycle, I'm going to capture. What's my step size, though?
Pi over 8.
Pi over 8. So something is not a bad idea. let's see, pi over 8, 2 pi over 8, right? 3 pi over 8, 4 pi over 8. Are you with me? So pi over 8. 2 pi over 8 is pi over 4. 3 pi over 8. What's 4 pi over 8?
Pi over 2.
Pi over 2. 5 pi over 8. 6 pi over 8. 7 pi over 8. 8 pi over 8. That's what calculating step size does for us. Because all I did was I made my scale according to the step size, right? And I don't know why I write so tiny. I'm sorry. Now I can zoom in a little bit. So where's our cycle start again? Where's it begin? Pi over 2. And what does sine do at the beginning?
It goes up.
No. At its first point, where is it? 0. Yes, now we got to stop and think. My amplitude is 3, correct? Yes, sorry.
If the cycle starts at pi over 2, why did you start at pi over 8?
Just because here's 0, and I know my step size is pi over 8,
Okay.
right? So I can just do that. The one that we did yesterday where I did it on another sheet of paper is because our step size was so different from where we had to start that it just would have been kind of gross to try to get there. I don't know if you guys are with me or not, but I can do this one. This is not too bad. It didn't take too long to do the step size and get to the beginning. Okay. Where am I going to go from to? Because did the midline change? The only time the midline would change is if I actually move the whole thing up or down, right? And I didn't. There's no plus or minus anything out here. Midline's still 0, so I'm still going to go between what and what? Not still, but what am I going to go between? No?
No, 3 and negative.
3 and negative 3. But there is a reflection, correct? So normally what does sine do? Starts at 0 and then it, like Mike said, it goes up. All right, what am I going to do now? Start at 0 and go down. Okay. Yes.
So for the first chunk of the points, you don't grab anything?
Not yet. I mean, if I wanted to, like you were saying, I'm going to show you something about the 2 cycles thing. I'll do that in a minute. Okay. What I
For
go ahead.
a problem like this, we don't do the parent function of sine.
No, and I want you to see why. Based on how much it compresses and so forth, your scales could be so different. So if I try to draw my base function 0 to 2 pi, and then my scale is something silly, I would have this whoa, and then this. So this is one situation where there's just so much going on, we don't graph the base function on the same graph because it can have vastly different scales. Does that make sense? Okay. So what I really want you guys to get, let me try to do this. Let me see if you guys are cool with this. That's where ours is starting, correct? All right, let me see if I could do this. I wish this wasn't here, but it is, so it's too bad, Jeff, so just do it. Normally, sine starts at 0, correct? And then it goes up at pi over 2. And then it goes down at pi, yes? And then it goes down 3 pi over 2, and then it goes up at 2 pi. That is going to fit here. Each step is going to hit, now we're going to have to do the reflection, but each step is going to hit the next extreme. That's the importance of figuring this. Now I've got my one cycle fits here. I've got my thing chopped into 4 parts. So I know at this part is normally going to be at the maximum high, but because this dude reflected, it's going to be here. Then it's going to go to 0. Then it's going to go to here. And then it's going to go to 0. That's the importance. If I know the step size and I know where it starts and ends, I'm golden. And if it reflects, I just go to the other extreme, the first step. I really don't know if that makes sense, okay? Now, some of the book wants us to do like 2 cycles, and I think I told you about this. And personally, it's a little silly, but let me see if you guys understand. Let me fill this in first. So I've got this going on. Wee-haw. Woohoo. That's gross, Jeff. Oh, well, too bad. All right. Let me ask you, if I start going back, the beautiful thing is now, if I start going backwards, I just keep doing the same shit. Didn't it just come from here to there? Where's it going to go next?
It's going to go up to 3.
Yeah, if I start going backwards, I don't even have to really think too much. I just, yeehaw, woohoo, wee. Oh, shit. Ooh-wee. All right. Sorry. I don't know if you guys get that. By the way, before I forget, I just wanted to point out Joe for all of his beautiful Halloween spirit. If you haven't seen Joe's costume, I just want you to see that. He's got his second level to it, but maybe we'll just keep that put away because it freaks me out. Okay. Not really, but I will. So there I've got 2 cycles, correct? So that's one way to do it is once you get one cycle set, you can just sort of just keep going. And I really want you guys to get this. All the work we do here makes this shit that easy. Because I know what sine does. Starts in the middle, goes high, goes, if I flip it, okay, starts in the middle, goes low, goes to 0, goes high. Yes?
What if it starts at pi over 8 and then it asks for the cycle? Did it go right?
Yeah, whatever's easiest, you get that first, and then you just sort of go whichever direction you want to keep going. So make sure you give yourself enough room. And I don't know, screw it, no. I do want you to get a little practice on continuing, so the 2 cycles thing is fine. On a test or something, I normally just ask for 1 cycle.
And even though it says that it starts at pi over 2, it still can go back.
No, I need everybody to be with me on this. How far does sine go? Forever. Then to say it starts somewhere doesn't make any sense. Are you with me? So what do we mean when we say it starts? The 1 cycle we're choosing to do first, we can see where it starts and where it ends. There are an infinite number of cycles. So I could start at negative 5,000 pi over 8 if I wanted to. Why would I? I don't know. But I could, because it looks the same. If we go up to 13 trillion pi over 8, I know it's the same, right? Okay. Maybe. Yes?
How do you know how big things are still? Because like our step size is pi over 8, but we started at pi over 2.
Yeah, so I need you to understand okay, here's my thought process when I went to do this. Pi over 8, pi over 2. They go beautifully together. 4 pi over 8s is pi over 2. So I thought, okay, if I do this step size, I can actually get to pi over 2, and it's reasonable, right? The problem we did the other day was unreasonable. I think it was started at pi over 4, and the step size was pi or something. I can't remember. It was just so out of whack, right? Okay, maybe you guys are with me. Okay. So, real quick, if I would have done this, +1, you could just do all this work, do this dotted, and then just add 1 to all the points. Does that make sense? What would it go from to then? Range.
4 and negative 4.
Careful. I want to move it up 1. Up 1.
4 and negative 2.
Yes, negative 2 to 4. I like it. Is that cool? What would the midline have been?
What?
Where is it right now on this picture?
0.
Y equals 0. Where would it be now? Y equals 1. Yeah. So to look at it, it would go, this would go up 1, this would go up 1. I'd have to make a better scale. This would go up 1, right? So then my midline would just go up 1. The midline should always be equidistant from either extreme. You guys, yes?
Why would it be 2 except like different values, 2 and 4 rather than 4 and 4?
Oh, because I'm not expanding it. I'm not stretching it. I'm just moving everything up 1. So this used to go down to negative 3. If I move everything up 1, now it only goes down to negative 2. This goes up to 4, yes? Okay. All right. Okay, so let's do this. Let's look at, no. We've already sort of done this. Yeah, maybe I could do that. That would be easier. If I could find it. Oh, here we go. It's not the best. If I wanted, see, this was the 5 sine blah, blah, blah. That was the example I gave you. If I had to actually graph 5 cosecant of the same blah, blah, blah. I don't know if you guys remember how to do this.
It'd just be the reciprocal, wouldn't it?
Sounds simple. Where would there, now real quick, What's the relationship with, yeah, it is the reciprocal. So cosecant is 1 over sine. Where would 1 over sine have issues when the output for sine is 0? Where's the output for sine 0 for this graph? Isn't it right here, right?
Still 0.
So there would be an asymptote here. Does that make sense? So if you have to graph cosecant, you pretend like it's sine and you do all the steps we just did. And then you graph the cosecant. So how does that work? Once I got the sine thing done, I can see where my asymptotes are. Does anyone have any issues why I put the asymptotes where I did?
No.
It's where the sine is 0, so of course cosecant would be 1 over sine. It's going to have an asymptote. What's the value of sine? Well, this is going to be a little bit weird, but
It's going to be the opposite of that, isn't it?
what's going to happen is, this is kind of cool. Whatever the top of the hill is, you just do this. Because as sine gets smaller, won't cosecant get bigger?
Well,
As sine approaches 0, 1 divided by small gets really big, and that's why those asymptotes are there. So then you can do the same thing here.
huh.
So the graph of cosecant and secant, you've got those. If you can graph sine and cosine, and some of you guys are like, no, I'm still learning to do. Okay, the minute you know how to do sine and cosine, it's one more step to do secant and cosecant. So there's no like special way to do secant and cosine. You just graph sine or cosine and then plop these little cups on top and bottom of it. How's that? Is that all right? So the one thing we haven't looked at yet is what? Tangent and cotangent. So let's look at tangent. What's one of the basic definitions of tangent in terms of other trig functions?
Cosine, or sine over cosine.
Sine over cosine. I love it. So where will tangents, why are you writing so much, Chefs? Horizontal asymptote, not horizontal, vertical asymptotes be? We make that possessive. Okay. Yeah, sorry, say it again. When cosine is, does that make sense? Same thing we just did. What's on the bottom of tangent? Cosine. There's going to be a vertical asymptote when cosine is 0, correct? So when is cosine 0? No, when is cosine 0? At what angles? Give me radians. What's cosine of 0?
1.
1. Because it loves it there. It's all x. Yeah. Pi over 2. Give me another one. Oh, yeah. 3 pi over 2. Give me another one. Negative pi over 2. Give me another one. Negative 3 pi over 2. I love it. Give me another one. 5 pi over 2. All right. So all the odd multiples of pi over 2. Because that's when it hits the y-axis and cosine hates it there, yes? Little cosine turtle is like, oh, shit. Goes all the way inside of his shell. I don't know.
So why wouldn't you say cosine of x would be 1?
Sorry?
I was thinking of it as like, oh, since cosine. Oh wait. Okay. Now, yeah. I get it.
Okay, okay.
Sorry.
So tangent will have a vertical asymptote at these locations. Okay, I like it. Now, something else to think about tangent. Let me see if you guys can do this real quick with me. Stay with me now. Get out there, Jeff. Really? In quadrant 1, sine and cosine are both positive, so of course tangent is positive, right?
Yeah.
Quadrant 2, tangent is going to be negative. Quadrant 3, it's going to be positive again. The funny thing is, tangent, it gets through all of its values in pi. After pi, it's gotten through all of its values. So it starts at 0, goes to 1, goes to infinity, goes back to -1, goes to 0. I'm sorry, I went that backwards. Infinity, anyway. So in pi's worth of time, it actually gets through all of its possible values. And you can see that here, real quick. Between these two, any two asymptotes, how wide is that? What's 3 pi over 2 minus pi over 2? 2 pi over 2, which is pi. So the period for tangent is pi. So not surprisingly, I haven't said this yet, but like the base cycle, for sine, we start at 0 to go to 2 pi. Same thing with cosine. With tangent, we choose these to be our base cycle. And once we graph it, it just repeats that forever and ever. I just basically gave the game away, but too bad. So if I want to graph tangent, stay with me now. We're going to do it specifically one cycle between these two. So we already said there's asymptotes at negative pi over 2 and pi over 2. Good. You're going to have enough time, I think. Now, can somebody help me out? Negative pi over 4. Negative pi over 4, right? Why is tangent awesome at pi over negative, any pi over 4? Because sine and cosine are... No, sine and cosine, what I'm looking for is what's special about the relationship between sine and cosine at a 45-degree angle? They're equal. And since tangent is the ratio of them, tangent's going to be 1 or negative 1 at every pi over 4, 3 pi over 4, 5 pi over 4. Does that make sense? So at negative pi over 4, is it going to be positive or negative 1? Negative 1. Good. At 0, what's tangent of 0? Well, what's sine of 0? 0. Cosine of 0? 1. 0 over 1, 0. At pi over 4, we already went through this, but now I'm here. So is it going to be 1 or negative 1? 1. And then it goes to infinity. So it looks like this. Oh, I don't know if I'm going to be able to graph this well. It's hard to get the real curve in there because it's so freaky. Okay. It looks kind of like an elongated cubic. Doesn't it look like a cubish, like a x cubed? But it's just sort of like been elongated, so it doesn't quite have that, normally a cubic in the middle looks more flat like that. This sucker's been like stretched out a bit. Okay. So it's not a straight line. Be very careful. It's not a straight line. But it's, and also my scale sucks, but it's supposed to go a little bit through and then curve back around and go up. Yeah. Okay. And then guess what it does? It just freaking, so now I can go over to 3 pi over 2. And it's going to just repeat the same shape. Wee-haw! And it's going to repeat the same shape. Wee-haw! Forever and ever and ever and ever and ever in both directions. Just like, because cosine and sine repeat their damn things forever and ever and ever and ever. Okay, maybe. So, when I have sine or cosine, and I figure out what k is, how do I get the new period? Divide what by k?
2 pi.
2 pi, because sine and cosine have a period of 2 pi normally, so I can change that. What if I have tangent and I figure out what k is?
Then you have
What's tangent? Pi over k, kick ass, right? Because tangent's period is pi, and then when I get k, I can adjust it. So you're going to be really careful. Sine and cosine, period 2 pi, k is going to adjust that, so 2 pi divided by k. Tangent starts us at pi divided by k, because now the k is going to adjust that. Okay, I like it. So let's do this. Let me give you this, and I think I'll do number 2 first, because we just now talked about tangent. Very quickly through some little Halloween type stuff on there.
This is section 5.3, 5.4.
I think oh shit, my poor little camera. All right, let's see. It's not, yeah. Oh, that's from the old book. I'm sorry. we're obviously not in chapter 5 anymore. The old book I used to use had
8.3,
trig and 5. Yeah.
8.4.
Maybe not. I don't know. All that matters is this is how to graph tangent and stuff. Sorry, I'll figure it out in a minute. Now, real quick. Oh, all right. I should have made this point earlier. Do you see how this goes through 1 here and here? And also, is there any sense to talking about an amplitude of tangent? Because how far up and down does it go? For frickin' ever. So, but notice I do have amplitude, but it's in quotation marks, right? Because I'm weird. But the idea here is, if this was 2 tangent, wouldn't this point go to 2? Do you see how that's sort of like the number in front still, it doesn't mean amplitude, but it does give you some idea about how stretched out it is. Yeah. So normally, so what's the amplitude here?
4.
4. What that means is at pi over 4, negative pi over 4 is going to go to 4 and negative 4, right? Okay.
Oh, okay.
Take a minute and factor the inside of that for me. All right, what do you guys get? Kick ass. Kick ass. So far, nothing's really different, right? What's K? 2. K's 2. The period, again, whatever the original period is, I'm going to divide it by K. So now I'm working with tangent. So that'd be pi divided by 2. What's the step size? Yeah, divide that by 4, right? So it'll be pi over 8. I like it. So just to point this out, for sine and cosine, 0, pi over 2, pi, 3 pi over 2, 2 pi, right? You with me? So the step size, there's 4 steps. That's why we always just cut the period in 4 parts. Tangent, negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. It's also got those, and it's still 4 steps. Okay. Phase shift. Blah. I'm sorry, let's do it again. Pi over 4 to the right. I love it. Now, again, the funny thing about this, the way that I do this, we actually never really directly apply this. But I'll show you, almost everything we do is sort of like a check and balance on the other stuff. So I'll show you. Now look here, does this make sense? Where does tangent normally start? Negative pi over 2. And that's where there's an asymptote. And then it ends where there's another asymptote at positive pi over 2. So look what I did. Set the inside equal to where it normally starts, so I can see where this dude starts, right? So how do I solve this? Well, let's see. I would add pi over 2 over and get 0. Divide by 2 and I get 0.
Oh, yeah.
Did I copy that down? Yes, I did. Okay. Now, let me take a moment. I kind of want you to connect with what's happening here because, so let's see if you guys pull this. So normally tangent goes from negative pi over 2 to pi over 2, correct? And there's asymptotes there. This is kind of new to us, but that's why it's kind of nice to repeat this. The very first thing we kind of looked at was what K was and what the new period was, correct? So didn't I chop everything in half? Didn't I smush this thing? Are you with me?
That has to be a 5 over 8.
Wait. Let me get there.
Okay.
So normally it goes from negative pi over 2 to pi over 2.
Yeah.
This got compressed. Is everybody with me?
Yeah.
By a factor of 2. So now it would go, before I do anything else, if I just do the compression, now it's from negative pi over 4 to pi over 4. If I smush it by a factor of 2, it doesn't go from negative pi over 4 to pi over 4 now, right?
Yeah.
Then we moved it to the right pi over 4, correct?
Yeah.
So now that's why it starts at 0. I just want the beginning to be 0. Why does that make sense? I smushed it, and then I moved it over, and that exactly lines up with 0 now. That's why it starts at 0. So what will be at 0 in our graph? An asymptote. And now there will be an asymptote here. So if I add pi over 2, what is pi over 2 plus pi over 2?
2 pi over 2.
Which is the whole pi, right? So if I have half a pi plus half a pi, it's the whole pi. And then divide by 2. Now why does that make sense? It just says, this says it starts at 0 and it ends at pi over 2. What does that confirm? What's our period?
Pi over 2.
Hey, see how that confirms it, yes? A whole cycle takes pi over 2 long to go through, right? I don't know what I just did. Oh. Okay, let me stop for a minute. And again, give this time to sink in. You haven't really had much time to work with sine and cosine. We're already doing tangent. But the nice thing is, even though you interpret some of these things differently, they're all the same things that you kind of look for, right? Just got to be a little careful about the period and the beginning and ending being different. Okay. So now, my step size is pi over 8. So I can make be pi over 8.
Pi over 8, pi over 4, 3 pi
Good. 2 pi over 8, which is pi over 4. 3 pi over 8. 4 pi over 8, which is pi over 2. And that is exactly, I'm sorry, you guys don't see shit. That is exactly where I want to end, right? So that's kind of nice too. You do the step size, and you do end up starting and ending where you're supposed to. What's at 0 again? Asymptote, blah, 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 blah. And what's at pi over 2? Asymptote, blah, 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 blah. Now what I normally do is this. Right in the middle, what's tangent? Right in the middle, what does tangent do?
It
Crosses the x-axis. Good. And these two are where it's at, kind of like a midpoint, sort of. Like, it's not the amplitude again, but what is the amplitude? Bless you.
4.
Infinity.
So at 3 pi over 8, it normally goes to 1. Now it's going to go to 4. At pi over 8, it normally goes to -1. Now it's going to go to -4. So now you can just fill it in. Please do what you can to make sure it doesn't look like it's a straight line. The curve is very subtle. If the book wanted another cycle, do you see how I can just do the reflection of what we've done? So I go back to negative pi over 2, blah, 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 bless you. And then there'd just be, bless you, Wee-ha! Right? Now you can put some more details in there, but. So tangent's kind of nice because each cycle is sort of contained. So to graph another cycle is a little bit easier. Just do that same contained thing again, right? Okay. It's funny because some of you guys are looking at me like, please start making sense. Yes?
For the beginning cycle and the end cycle, when we put a negative pi over 2 and pi over 2, what is that? Like, why do we put those values?
Because tangent, our base cycle, starts at negative pi over 2, ends at pi over 2. Why did we put 0 and 2 pi for sine? Because our base cycle starts at 0, goes to 2 pi. Okay. So you don't have to memorize as much as I could make you, but you still have to memorize some stuff. Yeah.
How do you get the step size of pi over 8?
So the beautiful thing about step size, sine and cosine, for example, I know we're talking about tangent, but let me just go 0, pi over 2, pi, 3 pi over 2, 2 pi's. Everybody with me? That hits the extreme values. Where is it maximum? Where is it minimum? Where is it 0? Is that all right?
Yeah.
So I break it up into 1, 2, 3, 4 steps. What is 2 pi divided by 4? 2 pi divided by 4. Pi over 2. Isn't that exactly the steps? Pi over 2, pi. 3 pi over 2, 2 pi. Isn't that exactly the step size for sine and cosine? So what do I mean by step size? I want to get to the next point where an extreme value shows up. So, for sine, just a normal sine. Bless you. For just a normal sine, where do the extreme values? We start at 0, correct? Where does it hit 1? Pi over 2. Where does it hit 0 again? Pi. Do you see how that's... Where does it hit negative 1? 3 pi over 2. And where does it hit 2? Where does it hit 2 pi? 2 pi probably. Where does it hit 0 again? 2 pi.
It is, yeah.
All right, there's a picture, blah, blah, blah.
It's 2 pi.
So, again, complete period, yes, is right there, yes? And I chop it into 1, 2, 3, 4 parts just to catch where this thing does. It's in this case, it's extreme values. For tangent, it's a little different because tangent doesn't have the extreme, the high and the low. It goes to freaking infinity. So what we do instead is we kind of capture these intermediate steps, which kind of makes sense because that's where tangent's going to be a nice whole number. It's going to be a ratio of sine and cosine. The sine and cosine are equal at that point, right? So the 4 steps, 1, 2, 3, 4 steps, correct? Same thing with sine and cosine. So that's why I would take the period divided by 4, and isn't that exactly what the step size is here? Isn't each one of these pi over 4? So if I smush it, I take the new period divided by 4, because I still got to fit 4 steps in there. So if I smushed it so it all fit in here, I would still have to do 1, 2, 3, 4. I'd still have to fit 4 steps in there. So I take the new period divided by 4, just to see when do each of these things happen. Does that make any sense?
Pi over 16.
Okay. Where's my little dude? There it is. Okay. So on this problem specifically, our period was pi over 2. So it's going to do its whole thing within pi over 2. If I cut that into 4 parts, I can see the steps. I know at the first step there's an asymptote. I mean, at the beginning there's an asymptote. Then the first step is where it hits 1 or negative 1 or whatever based on the amplitude number. Then it hits 0 at the next step. Then it hits negative whatever. And then it hits another asymptote, right? So those are the key spots. And what's beautiful is they just happen to be exactly by 4, right? 4 steps. Okay. Oh, you guys love this, I could tell. Okay. Let's see, what time is it? Oh, good. Look at that. Let's do another tangent before we do this cosecant. What do you got, Jeff? Sure, let's find out what happens together. So again, is everybody cool with the fact that an idea of amplitude doesn't mean shit when my function goes to negative infinity, infinity? There's no amplitude. But I can still use this number to tell me something. Right? That's going to be what it hits at the first step and at the third step. It's going to be what it hits there, right? What else can you guys tell me? Anything else you could tell me? Say again? Yeah, what's K? Pi. Careful. K is always the multiplier, right? Now, we haven't factored this yet, but somebody pointed out earlier, all right, you can already see K. It's right there. So what's the new period? What was it before? Pi. And now I divide that by k, right?
Pi over K.
1. So the new period is 1. How do I figure out the phase shift? What do I have to do? No, careful. I can't tell what's happening to x because there's something in the way, yes? What do I have to take out?
Pi.
Pi.
The x went 1 over 2.
Yes. Just each piece loses a pi. So what is the phase shift now? Now I can tell. 1/2 to the right. Okay, I think I need to zoom out a little bit. Ooh, there we go. All right, so let's do the beginning end real quick. Let's see, I'll put it over here. Begin, end. Where does tangent normally begin? Careful. Negative pi over 2. And it ends at, what am I doing? Stop it, Jeff. Pi over 2. Oh, I see. That's funny, Jeff. You made something almost like what we already did. It's okay. So here, if I add this over, I get 0. So I get x is going to start at 0. Is that all right? Oh, again, tangent. Where's the base thing we did? Where's the first asymptote? Negative pi over 2. So our base tangent starts at negative pi over 2, and it goes to pi over 2. Totally, 1 cycle is pi. I love it. So if I start at negative pi over 2, and I go to pi over 2, isn't that pi? Half a pi, full pi. Yeah.
Why is it in beginning, why does it equal negative pi over 2 and in the end pi over 2?
So again, our basic cycle starts where? Negative pi over 2. So it starts when the inside is negative pi over 2, and it ends when the inside is positive pi over 2. So if I just make the inside equal to those two things, I can see where my new stuff starts and ends. And if you think about it, well, no, I'm not going to go that far. So here, if I add pi over 2 over, I get pi. If I divide by pi, I get 1. How does that match up with what our period's supposed to be? Yeah, it's 1. It's supposed to be 1. It is 1. So the more you do this, the more you'll realize you don't need this, but it's kind of nice to check and balance yourself in a few different ways. Okay, so now I'm going to start at 0, and I'm going to go to 1. What's my step size? Yeah, 1/4. I love it. So let's see. Chop, chop, chop. So 1/4, 2/4, 3/4, 4/4. Yeah, this is well, it's okay, Jeff. What's going to be at either end? Asymptote. What happens right in the middle? This is how I do this. What happens right in the middle?
Where it crosses over.
Yeah. And then here is where it's the negative, and what's this going to be? Yeah, negative 2. And here, here's where it's the positive, so that's going to be 2. So then it goes, very subtle curve, very subtle curve. Ah! Okay. Let's see, real quick. Don't worry, just watch. You don't need a calculator, but just plug this in the calculator. What do you think I have to be careful about as I do this?
Make sure that you're
What should I be in?
radius.
Radians, totally. So let's see. Here's something really kind of cool. Let's see if you guys see this. If you hit the zoom button, do you see something that looks interesting?
Z trig.
See. See what that does. Look at that. Wah! All right, let's make this match with our scale, yeah? So here's what I would do if I were you, if I'm trying to compare my graph. I would go to window. I'm gonna go like, let's go -1/4. Is that cool? Like -1/4, just to give it a little, and then go up to like 5/4. Do you guys see what I'm doing? Give it a little space this way, give it a little space this way.
1.25.
And my, did I do it? Yes. And then my y, I can make it, let's do -3 to 3. Do you guys see that? Give it a little bit. So now it should a little better match. Let's see if it does. There we go. And of course we can see a little bit of the next cycles on each side, right? But that's, see that? There, look at that. Wee-haw. Yeah, Jeff, you know what you're doing. Oh yeah, that's right. But I mean, so you can use the graphing calculator to help you check your answers with these problems, right? Just to be pretty good about the window. All you do is you look at what you did and you make the window, the scale the same. And then it kind of is easier to check. So this little piece there is this other cycle doing its thing. So that's that little piece. And then this little piece down there is the other cycle doing its thing. Okay. Kind of nice. Okay. Yes. So what I know is that tangent always has asymptotes in either side, and in the very middle, it goes to 0. Right? Because at 0 degrees, cosine is 1, right? Let's do this. At -5/2, tangent goes to infinity, right? And then it starts to get smaller and smaller, and then at 0 degrees, tangent's going to be 0, because sine is 0 and cosine is 1. 0 divided by 1, right? So I know right in the middle of its, so here's the period, -5/2 to pi/2. I know right in the middle, it's 0. So whatever I do, I can really go to the middle and go, okay, you're 0. Unless, of course, it's been moved up or down. Are you guys with me? Okay. Oh, you guys love this stuff. Okay. Coming back to this guy. I'm going to let you try to get as far as you can. Just to give everybody a little hint, what do you pretend like you're doing? Good. You do everything, including graph it as if it was sine. But when you graph it, you do a dotted line, because it's not your answer yet. The last thing you do is just plop the u's on top and bottom. Okay, see how far you can make it. So pretend like this is sine and do the whole thing. And I'll just, stand here. Or you can call me over if you need help. Just real quick. Amplitude should have been easy. K is pi/2. Period is 2 pi divided by, sorry?
It's 4.
What's 4?
The period.
Oh, okay. Sorry. Sorry, Sarah. I was trying to do this step by step. So 2 pi divided by pi/2, which is 2 pi times 2 over pi, right? That's all you got to do. That's how you divide fractions, right? You multiply with the reciprocal, so the pi's cancel. And like Sarah says, you get 4.
But then with the end cycle, that's not what you get.
Well, let's see. Let's see, pi. First thing I would do here, what do you guys think I would do first? I don't like those fractions. So I multiply everything by
2.
yeah, I multiply everything by 2. Oh, where did it begin, by the way? Let's see. So again, I can multiply everything by 2. Is that cool? You don't have to,
But even if you do it the other way, you still won't get.
what do you mean? Let's see. So here we get, what do you get when you solve this? You divide by pi, subtract 1, you get -1.
Mm-hmm.
All right. This one, if you subtract pi and divide by pi, you get 3. How far is it from -1 to 3?
Aren't you supposed to get the period though?
Yep. What's period mean?
For
Why? Now, real quick. I think this has come up a couple times. Where does sine and cosine start? 0. And if their period is 2 pi, they end at 2 pi. I think a couple of you guys are focusing too much on where they end is supposed to be the period or something. No, they just happen to start at 0, so they end at the period, because that's how far away. If my period is 4, and I start at -1, I'm supposed to end 4 later. And what's -1 plus 4? 3. Cool. So real quick, Sarah, it's just because sine and cosine both start at 0. So what, if the period's 2 pi, I stop at 2 pi. If I started at -pi and I go 2 pi further, I would end at positive pi. The period is the distance between where I start and where I end, because that's how long it takes to go through a cycle. So if I see where I start and I see where I end, if I take the difference between those two, it better be the period. And 3 minus -1 is 4. Okay. Going back real quick to this guy. Well, again, this was a little bit, it starts at 0, right? So that's why this is pi over 2, because 0 plus pi over 2 is pi over 2. That's what the period does. -1 plus 4 is 3. That's what the period does. What did you guys get for step size? Yeah, so I would take the period, but I would divide it by 4. 1. Right? All right, step size. How many steps do we always take? 4. Within one period, correct? So I always can just take the period, divide by 4. Just chop it into 4 steps.
I'm still not understanding like this begin and end cycle on this side, because on the other side the end cycle.
Totally. Guys, so which function are we working with on the back? Where does tangent normally start? -pi over 2. Where does it normally end? That's why, so we find the beginning, I set the inside equal to where it normally starts, and I set the inside to where it normally ends. Cosecant is based on sine. Where does sine start normally? 0. Where does it end? 2 pi. Okay.
But how does the end result of the end cycle not equal the period?
I need
If
you
the
to
rest of the
desperately
the
need you to
rest of
understand.
the-
There is no reason it should. If I start at 5 and my period is 7, so it takes 7 to get through a full cycle, where would I end? If I start at 5 and it takes 7 to get through a full cycle, where would I end? 12. Is that cool?
Yeah.
If my period is 3 and I start at -1, now let's do this. If my period is 4 and I start at -1, where should I end?
But why on the other ones did it?
Because where did it start? Where did it, on the other side, where did it start? Where does it start? 0. And what do I get when I add the period to 0? So again, this is what I think. You guys see this number and you go, oh, that's the period. It's always going to be the period. No, why is that the period? Because the first number was 0. So when I add the period, I get the period, right? If my first number is not 0, when I add the period, I'm not going to get the period. I'm going to get whatever number that is. Yeah.
So our graph is going to end at 3.
Good.
It's not ending at 4.
No. If it ended at 4, the period would be 5. Yes? Because where did this sucker start? -1. So if this dude started at 0, it would end at 4. Through all, and in fact, we haven't done this yet. Let's do this real quick. This I should have done this, but do this real quick. What did you guys get for this? What can you factor out?
A half pi times, a half pi x plus pi.
No, careful. 1. Because pi over 2 divided by pi over 2 is 1.
Oh, yeah.
Right?
Okay.
So what would this be? This would be a shift by 1 to the left, yes? So if this started at 0, it would end at 4. You guys all agree with me because the period's 4. Didn't I just shift that back 1? So if it started at 0, we'll go to 4. Now it starts at -1, ends at 3. Because everything's shifted back. Shifted to the left, 1. You guys see that? Okay. Yes?
Are these only tangent doing to have asymptote?
True. Sine and cosine don't have asymptotes of either type, right? They sort of have bounds, but they definitely don't have asymptotes. They don't have something that they have to approach forever, right? They just sort of go, oh, I got to turn. Oh, I got to turn. Tangent's got these asymptotes that kind of contain it. Yeah. Okay. All right. Everybody make a face right here that indicates how you're feeling. Okay. I'm a little frazzled, but I'm overall happy. So you guys, if you need to get something, you can draw a little face like, you know, not like that, maybe like this. Math boy in your faces. Yes.
What's our step size?
Yeah. How do we always?
Pi. Isn't it 2 pi over 4, which would be pi over 2?
Okay. So if the period was 2 pi, then it would be 2 pi divided by 4. What is our period? 4. So then I chop that up into 4 steps.
But
So if I had a sine thing that I did nothing to, the step size would be pi over 2, right? Because 2 pi divided by 4. If I compress it, if I have to fit 4 steps into that little compression, that's going to be different step size, correct? I'm going to have smaller steps. And that's exactly what happened here. Well, no, this one this is sort of a weird one because we went from pi to just whole numbers because our k has a pi in it. Anytime your multiplier has a pi in it, you're going to go to whole numbers instead of pi stuff. So whatever the period is currently, I have to cut that into 4 steps. What is our period for our function? 4. So I'm going to cut that into 4 steps. Okay. So now I'm going to start at -1, right?
You can't see.
Sorry. And I'm going to go up to, Jeff, you can do it, buddy, up to 3. Now, have I flipped this at all? Is this any reflections going on? So the really beautiful thing, I've done a lot of work. There's a lot of work here. This should be the easy part. So what does sine do at the start? Where is it at? At 0, right? That's what sine does. Starts at 0. Then it goes to, what's this going to be now? Careful. Good, because the amplitude's 2. Now, when I draw this, it's going to be dotted because that's not going to be the answer. This question is not sine, is it? So it's not going to be the answer.
It's gonna go to -2, right?
No, because it hasn't been. So again, is there a negative to flip it? Nope. I know cosecant is 1 over sine, but we graph sine, and then the flip is when we put the cups. Yes. Okay. And again, give yourselves a break, all right? Can everybody just give yourselves a break? I don't want to make it seem as if I'm expecting too much from you. I'm trying to show you how this all works. You've got to give yourself time to let it sink in, right? Good, good, good. Healing breath, all right? I'm not grading you yet. I will, because, it's part of my job. But again, I desperately want you guys to be with me on, here's a normal sine. Normal sine does this stuff here, right? Weehaw! That's what it looks like. If I do all the work to figure out where's it start, where's it end, what's the step size, now I can just take that, plop it on in, right? So it starts here, goes to high, goes to 0, goes to low, goes to 0. This step should be the easy step. Now you got to be careful if it's reflected, but then instead of going high, you go low. When they go high, we go low. Maybe not. I don't know. And then, oops, don't forget. So now I'm going to make it dotted. Why am I making it dotted?
Because it's not
Kick ass. Now, cosecant, 1 over sine. Where will the asymptotes be based on what I've drawn here so far?
1 and -1 and 3.
Yeah, it'll be at -1. Sure, 3 and 1. Is everybody cool with those asymptotes being put there? Yes. Yeah, tangent will have asymptotes, and cosecant and secant will have asymptotes. I like it. Why do those all have asymptotes? And cotangent will have an asymptote, right? Why do those all have the asymptotes? Because they all have trig functions on their bottom that can be 0. Yeah, sine and cosine, they're just freaking sine and cosine. The denominator's 1. They never go to infinity, right? Okay. So now watch this. Yes? Why is there a... Oh! Cosecant is 1 over sine. Wherever sine is 0, cosecant will be 1 over 0, which is undefined, so that would be where there's an asymptote. Anywhere I see the output as 0 for my sine, that's going to become an asymptote for my cosecant, right? Because 1 over 0, asymptote, goes to infinity, or negative infinity, right? I really want this to make sense. At these inputs, don't they have numbers that get smaller and smaller and smaller? So when I put them into 1 over small is bigger, bigger, bigger. 1 over small is bigger, bigger, bigger. So I literally just have to draw kind of like, it's not really a reflection, but it's sort of like a reflection. Just turn it this way. So secant will have the exact same shape. It's just going to sit on a cosine function, right? Okay. I like it. Good. I can see some of you guys are sort of getting off your own back a little bit. You've got to... This is the first cosecant we've really officially graphed. You're not supposed to understand everything in the world yet. Whoa. Except for the fact that that's all for today. Okay. Our next test is Monday, is that true?
Yeah.
Yeah, exciting times. So, you're all going to be, I didn't announce a quiz yet, did I? No. We just had a quiz, but we're going to have another quiz because I want to really push my luck with everybody. See how much I'm going to make everybody hate me. So quiz, it's got to be, does it make sense? It's got to be, no, it can't be Thursday. Why not? It has to be tomorrow. Why does that make sense? If we make it Thursday, you get the quiz back on the day of the test. You have no time to make corrections. That would be.
Then what are we gonna have on this quiz?
Well, let's find out. So quiz tomorrow. Oh, I knew I was gonna I'm gonna make a lot of friends. Okay.
Well, what if we just have the exam like on Tuesday and then we have the quiz on Thursday and have Monday to make the corrections?
And then have the,
Just like a
and then
thought.
have
All right,
the
okay.
test on
All right.
Tuesday.
I'll do this, guys. I'll do this. We are. See, this is all it takes. I'm a reasonable person. So we are a little behind my new schedule. So I'll do this. I'm not going to promise anything about the day of the test, but I will consider changing the homework sheet again, which is great. We'll see. So I'll say this. No quiz tomorrow. Okay? All right. And just be happy. All right. Yeah, I'll consider it. I'll try to work on that for tomorrow. And I'll bring an updated homework sheet, or at least put it up on Canvas if I decide to change. Something's going to have to change because we are, I don't know if you guys realize, we're a little behind where we should be. All right. And that's, mostly my fault, which is fine. So, yeah, I'll work on that. No quiz tomorrow. Okay? Might be a quiz on Thursday. Just be ready. Right? Okay. All right, guys.
Thank you.
You're welcome. Better thank you. No. You're